Our next topic in discussing enthalpy is called standard enthalpies of formation, and that's abbreviated delta H with the subscript F with a naught up at the top. So the standard molar enthalpy of formation is the difference in enthalpy between 1 mole of a compound in its standard state and its elements in their standard state. And I underline the 1 mole here because as we go on into chemistry, I see this come up a couple times where students don't recognize that the standard enthalpy of formation is for 1 mole of product where we have all the elements in their standard states. So if we wanted to calculate the delta H naught of formation for PCl5, if we were given the following reaction, we can say that PCl3 as a liquid plus Cl2 as a gas, remember that Cl2 is diatomic, giving PCl5 as a solid, and we're given the delta H naught of reaction is going to be equal to negative 124 kilojoules, and the delta H naught of formation for PCl3 is going to equal negative 319.7 kilojoules. So one of the things that we can take away from this and calculating a standard enthalpy of reaction, our delta H naught of reaction is going to equal the sum of N, which is the number of moles, times the delta H naught of formation of the products, minus the sum of N, which is the number of moles, of the delta H naught of formation of the reactants. So what this is going to tell us is that the delta H naught of the reaction is going to equal the sum of the delta H naught of formation of the products, which would be 1 times the delta H naught of formation for PCl5 minus 1 times the delta H naught of formation of PCl3 plus the delta H naught of formation of Cl2. Whenever we have a compound that's an element in its elemental form, such as Cl2, our delta H of formation is going to be 0. So this tells us that, and we're given the delta H naught of formation for the reaction, so that's going to be negative 124 kilojoules is going to equal the delta H naught of formation of PCl5 solid, which is what we're trying to calculate, minus the delta H of formation of PCl3, which is negative 319.7 kilojoules, plus 0. So when we rearrange this equation and look at the algebra, we find that the delta H naught of formation for PCl5 is going to equal negative 443.7 kilojoules. So when we go through and we calculate this delta H not a formation, we need to use the overall equation. We need to make sure that it's balanced. And we can use this sum of the delta H of formation products minus the sum of the delta H of formation reactants equation. So this is what we will use when we do any type of calculation of this sort. And in the next video, we'll go over another reaction involving the combustion of methane.